Hello everyone. I'm Srinivasan from RMDEC Engineering College. In this video's lecture, I'm going to talk about activation functions. So activation functions are very important whenever we talk about artificial neural networks. It is used to determine the output of the neural network model, including deep neural network model. And activation functions are very important to decide the accuracy, control the convergence speed, and determine the computational efficiency of training in the neural network model. Typically, activation functions are used to normalize the output of the artificial neuron within the range of 1 to 0 or -1 to 1. Let us see why we need artificial functions. So typically, the inputs are fed into the artificial neuron in the input layer. Each neuron has a weight and it is multiplied with the input number with the weight so that we predict the output of the neurons. The simplest formula to calculate the output of the neuron is the sum of the product of weight and input plus and bias. See, this output of the neuron in one layer will be sent to the neurons in another layer as input. Typically, the output of the artificial neuron is minus infinity to plus infinity. So to bring it down, we are using the activation functions. So this diagram shows how the output of the artificial neuron is controlled with the help of the activation functions. We are using two types of activation functions. One is linear activation function, another one is non-linear activation function. The linear activation functions, the output, okay, will be a straight line. So it is either 0 or 1. For example, the linear activation function is f of x equal to x. Typically, we are using two types of linear activation functions. One is identity activation function, another one is binary step activation function. The second one is non-linear activation functions. So it is used to produce the output in the form of some curves. So it is more generalized than the linear activation functions. And we are using different types of non-linear activation functions. Sigmoid or logistic activation functions, Tanach or hyperbolic tangent activation functions, rectified linear unit activation function, leaky or weakly rectified linear unit activation function, arctan activation function, and softmax activation functions. They are produced in a different form of curves. It means they are produced the values drastically differ from each output of the artificial neurons. So based on the requirements, we are using the activation functions. And the table shows the different form of activation functions that are available for finalizing the output of the artificial neurons. Thanks for watching this video.